All right, to get us started into the next unit, we're really just kind of continuing on with our trig. Starting off this unit, we are going to extend the right triangle trig that we focused on in Unit 6, and we are going to be looking at some trig that applies to just triangles in general. Today specifically looking at the law of sines and cosines. So let's start off by talking about the law of cosines. And I am going to go ahead and go through a quick proof of the law of cosines just so you see how the formula is created. Now, understand that our Pythagorean theorem, we should know, relates three sides of a right triangle. And again, the law of cosines relates the three sides of any triangle. The way that we're going to create this formula is from a right triangle. So what we have in this picture is we have triangle ABC, and notice that triangle ABC is not a right triangle. But what I'm going to do is drop down this perpendicular, this altitude, and basically what I've created are two little right triangles, okay? Notice that, and you should know this from geometry, so our angles are labeled in those capital letters. The side opposite the angle is the lowercase letter, okay? So we have side A, opposite angle A, we have side C, opposite angle C, and then this entire side B is opposite angle B. But once we drop down that altitude, I create then two different lengths down here. So we're going to call this length X, and then this length would be the entire thing B minus X, okay? So what we're going to do first is use Pythagorean theorem to write an expression for the triangle on the left, okay? Triangle on the left. So again, this is from the left. So using Pythagorean theorem for this triangle, it's just going to be x squared plus h squared equals a squared, okay? So the two legs are x and h, hypotenuse is a, okay? Now, we're going to do a similar thing for the triangle on the right. So this is going to be h squared plus our other leg is b minus x, so that's going to be b minus x squared equals c squared. All right, from here, what we would do algebraically is we would expand that binomial b minus x times b minus x. I'm going to go ahead and write out what that comes out to be. So when we multiply that binomial through, I have h squared plus b squared minus 2bx plus x squared, and again, that equals c squared. Now, here's where a little bit of algebra magic comes into play. So notice that I have a term h squared plus x squared in this equation. Well, in the first equation that I wrote, I said that x squared plus h squared equals a squared. So basically what I'm going to do is I'm going to replace those two terms with a squared. So I then have a squared plus b squared minus 2bx equals c squared. All right, we're getting there. Now, from here, what I'm going to do is I'm going to look at angle C, and if you didn't know how to do this proof, you would know that this is where I need to go, but so looking at angle C, I'm going to look at taking the cosine of angle C. So the cosine of angle C, we know, is our adjacent side, which is x, over the hypotenuse, which in this case is a. So cosine of C equals x over a. If I multiply both sides by a, I get that x equals a cosine of C. So what I'm going to do at this point is substitute a cosine of c in for x. And once I do that, I end up with what becomes our law of cosines. So again, replacing this a cosine of c in for x into this formula, I have that a squared plus b squared minus 2 a b cosine of c equals c squared. Okay, so all I did, so I had a cosine of c, I just put a in between the 2 and the b. You will typically see the law of cosines with the c squared first. So what I'm going to do is I'm going to erase this and just write in how you are normally going to see it, so you have this in your notes, okay? And you can write a similar law of cosines for really any side. So I could have b squared, that would equal a squared plus c squared minus 2ac cosine of b, and then finally the last one. And which one you use really just depends on what information you're given in the problem. Okay, so let's look at using an example of the law of cosines for a problem. All right, in the first example, it should say that a person leaves her home and walks 5 miles due east and 3 miles northwest. So she's leaving home, walking 5 miles this direction, 3 miles that direction. The first question is, how far has she walked? Well, don't make that hard. She walked 5 miles and then 3 miles. She walked 8 miles total. All right. Now the question is, that's really going to come in for our law of cosines, how far away from home is she? So with that question, now I'm looking for the distance along a straight segment from where she started her home to where she ended up with, okay? So here's where I'm going to write out and use that law of cosines. And then it's really just a matter of substituting in information that we know. So if I'm looking for that, that's essentially going to be my value of c. If you want to substitute an x in there, that's fine. It really doesn't matter. And then the other two values, a and b, those are from the other two sides of the triangle. So this is going to be x squared equals 5 squared plus 3 squared minus the quantity 2 times 5. So again, a is 5, b is 3, and then times cosine of angle C. Now, important thing to bring up. In this formula, this side is opposite this angle. So if I'm looking for this side length, then I have to use this angle measure, in this case 135, in for my formula for my law of cosines. So that's going to be 135 degrees. You will, since we're working in degrees, need your calculator in degree mode, so make sure when you're doing your calculations you have that correct. From here, guys, it's just plugging and chugging, really. So this is going to be x squared equals 25 plus 9 minus 30 times the cosine of 135 degrees, okay? and simplifying that a little bit more, so 34 minus then that quantity, okay? So from there, when you enter that on your calculator, you should be getting about 55.21, and then we would just take the square root of both sides to get C, or I guess X really. X is equal to about 7.43 miles. Okay, so again, that's the straight line distance from where she started to where she ended. Not the same as the path that she walked, really. Okay? All right, last part of this question is going to have us use the law of cosines in a different way, and that is to find an angle, okay? So this question is asking us, at what angle must she walk to go directly home? So we are actually going to be finding this angle measure. And so for that, if we said that 3, so we are looking for the angle she must walk to go home. So you might be wondering why it is this angle that we're trying to find. So keep in mind that she is over here. So she has to go home. She really has to turn basically at that angle, which if you think back to geometry and you know your alternate interior angles, that angle that she turns here to go home is really this angle inside the triangle. So we're going to find that angle again using our law of cosines. So we are going to be looking for angle B essentially, since we labeled this side B. So thinking about that, since I want to find angle B, we are going to use this iteration of the law of cosines. So I'm going to go ahead and just copy that down here. And then we're going to fill in all of the information that we know. So B for this value is 3. I'll go ahead and square that, which is 9. Filling in our other values, value A is 5, and then we found our value of C to be that 7.43. So I'm going to use both of those values. I'm going to go ahead also and square those as well. Actually, I'm not going to square that one because I don't have that value written down in front of me. And then minus 2 times 5 times 7.431, and then times the cosine of B. So remember, we're looking for that angle B here in a minute. So from here I need to do some simplification. So bringing down 9 equals, simplifying all of that gives me 80.21976 minus 74.31 cosine of B. And then from here it's just really some algebra. Just make sure you're doing your algebra correctly. So really the first thing that we are going to do, and so what I would suggest that you do with your calculator is have this value 9 in there. The first thing that we would do is then subtract the 80.219 value. Keep that in your calculator, and then we're going to divide that by the negative 74.31. When you do that much, you should be getting 0.9584 equals the cosine of B. So make sure that you guys know how to enter all of this correctly on your calculator. You should be following along with your calculators doing this with me. Hopefully you're getting to this point. And then going back to last unit, I know that if I take the inverse cosine of 0.9584, that will get me the measure of angle B, which turns out to be about 16.6 degrees. Okay, if you didn't get that, double check that your calculator is in degree mode. Okay, moving on, what we are looking at is next our law of sines. So you saw with the law of cosines, we use our cosine function. So you might guess that with the law of sines, we're using our sine function, which we are. One thing I do want to point out is the difference between using the law of sines and cosines. And really I should say when it's useful to use one versus the other. The law of sines is useful when you know a side measure and the angle opposite it. If you think back to the last examples, we were given two side lengths and an angle measure, but they weren't corresponding. They weren't opposite each other, I should say. Okay, so real quick, we are going to go through a little bit of a proof for our law of sines, similar to what we did with law of cosines. You can see the same exact picture that we had before. And what we're going to do here, this proof is a lot simpler than the last one is. We are going to look at angle C first of all, and I am going to write my sine ratio for angle C. So I'm going to say sine of angle C, and we know that sine is opposite over hypotenuse. The opposite side is H, the hypotenuse is A. And then I'm also going to do the same thing with angle A. Okay, so angle A over here, the opposite side here is H, same opposite side. The hypotenuse here is C. So you might notice that in both of these equations we have the value of H. So what I'm going to do in both of these is multiply both sides in the first one by A. That gives me sine of C. I should say A times sine of C equals H. Over here, if I multiply both sides by C, that gives me C times the sine of A equals H. So basically I just solved each of those equations for H by multiplying by the denominator. So I have both of these equations equal to H. We know that if two quantities equal the same thing, that they're equal to each other. So because A sine of C is equal to H and C sine of A is equal to H, then they have to be equal to each other. So just putting those two expressions equal to each other to write our equation. And then basically what I'm going to do is just some division to group our like variables. So I'm going to divide both sides by A and both sides by C. So the C's cancel over there, the A's cancel on the left. What that gives me is then the law of sines. So sine of angle C over side C is equal to the sine of angle A over side A. That is your law of sines. Okay. Now, you can make a very similar proof that would include angle B. I'm not going to do that, but just know that that's where it's coming from. Okay. So for any triangle, we have sine of A over A. And again, capital letters are angles, lowercase letters are sides. This is going to equal sine of B over B, sine of C over C. And what you're going to do is you are going to take any two ratios from this to use. So you might be using this one and this one, or these two. It really does not matter. It's just really depending on what you're given. All right, In the first example, it says that an aerial tram, I think that's this right here, is the aerial tram, starts at 1.5 mile from the base of a mountain, whose face has a 60-degree angle of elevation. The tram ascends at an angle of 20 degrees. What is the length of the cable from T to A? So with all of that being said in the situation, really what we're getting down to is what is the length of the cable from T to A? Essentially, we're looking for that value of side C. So if I kind of take a second to just look at what I'm given in the problem, I'm looking for side C. Notice I'm given the angle measure opposite that. I have angle A and I have side A. So because of what I'm given, I'm going to choose the ratio that involves angle and side A, and then I'm going to choose the ratio with angle and side C. And it's really, guys, just a proportion. Law of sines is so much simpler than law of cosines. We're just going to substitute in then what we know and solve. All right, so from here, angle A is 40 degrees, so I have sine of 40 degrees right here. Side A is 0.5. It's going to equal sine of angle C, which is 120. And then I'm looking for side C, so that stays there. And then I'm just going to cross multiply and solve. So doing that, I'm going to have 0.5 times the sine of 120 degrees equals C times the sine of 40 degrees. So from here you can probably see algebraically what we're going to be doing. I would be multiplying this quantity. Again, make sure you're in degree mode. So sine of 120 degrees times 0.5, hit enter, and then over here to solve for C, then I would be dividing by sine of 40 degrees. So when you do that calculation, we should be getting that the length of side C is about 0.674 miles. Okay. All right, so finishing this up, and I should say that there is an example in our notes using law of sines to find an angle measure, but you can work it in a very similar way. You would just end up taking your inverse sine for the angle measure. So hopefully that isn't a huge issue. But there is one thing that we don't talk about in Algebra 2 regarding the law of sines that we definitely need to bring up at this level, and that is what we call the ambiguous case. Okay? So the word ambiguous starts with the letter A. So does this word. And you might remember from geometry, when you're working with your triangle congruences, that angle side side is not a way to prove triangles congruent. Okay? And there's a reason for that, and it actually ties into why we have this ambiguous case for law of sines. All right, so A, ASS, angle side side, not the bad word. All right, so let's talk about what happens here. It says there's one drawback using the law of sines for finding angle measures. The problem is that the law of sines does not tell us the angle, but only the sine of the angle. And we should know from our unit circle that there are actually two angles between 0 and 180 degrees that have the same sine value. So what I mean by that is this. For example, let's say, like it says, the sine of some angle is equal to 1/2. That angle then could be either 30 degrees or it could be 150 degrees, okay? We really don't know based on this information, okay? So let's look at this example. Notice what you're given. That's what's going to clue you in. Remember, angle, side, side. You are given the angle measure, and then going around our triangle, we have side and a side. So when you are given that type of information that forms that angle, side, side, then you're going to have your ambiguous case. All right. This is going to start off the exact same way that we did the last one. So I'm going to take sine of the angle given, which is 40 degrees, and that is going to be over its opposite side. I'm going to set that equal to sine of theta over its opposite side, which is 8. Okay? From here, cross multiply again. So 8 times the sine of 40 degrees is equal to 7 times the sine of theta. Divide both sides by 7. So this quantity is just going to come down here. What I would suggest is that you calculate this in your calculator. So 8 times the sine of 40 degrees, hit enter, divide that by 7. You're going to bring that quantity down, but because we're solving for theta, what we have to do is we're going to take the inverse sine basically of that quantity that you get in order to get our angle theta. When you do that, the theta value that you should be getting is about 47.27 degrees. But again, that is not the only angle that has a sine value of whatever that was. Okay? So to find the other angle, which is what we have to do, all we're going to do is take 180 minus the measure that we got. So in this case, that would be 132.73. All right.